Hi there. In this video, we'll be going over how to set up and use the WASim tool, a web application that features a classifier to determine the purpose of WebAssembly modules found on web pages or uploaded for analysis. For those that aren't familiar with it, WebAssembly is the newest web standard designed to run computationally heavy web applications faster than with JavaScript. It features a portable and compact bytecode representation, as well as a text format suited for debugging. As the name suggests, WebAssembly is an assembly-like language, meaning that it lacks the familiar classes, functions, and variables found in high-level languages. This makes the language difficult to read for newcomers and tedious even for those that can read it. We developed WASim to leverage machine learning techniques to automatically scan WebAssembly modules and identify their use case. The goal is to help give developers a tool to understand what a module is doing without needing to learn the terse syntax of WebAssembly. So now we'll go into the steps for setting it up. We'll show how to run the containerized tool using Docker. We recommend using Docker to run the tool as it handles the prerequisites and allows the tool to run on any platform. For those that want to run the tool locally, steps to do this are outlined on the GitHub page, but for most users, the Docker method should suffice. So first, go to the GitHub page through the link in the description below. We really only need the database folder and the Docker composed YML for this, but we'll just go ahead and clone the project using the command git clone and then the clone URL. It may take a while to download everything as there's a lot of files. After that's done, we can cd into the clone directory and run the command docker compose up. Docker should automatically download the required images and start running the required containers, but this may take a long time depending on your connection. After all of the containers have been started and the RabbitMQ container shows that it's listening, the tool UI can be accessed by going to the URL localhost:4000, and that finishes the setup process. Now we'll show how to use the tool. First, we'll look at the case of uploading a file. You can optionally choose the classifier type of the 4 classifiers described in the accompanying paper. There is a neural network model, random forest model, SVM model, and naive Bayes model. By default, it's set to the neural network model as this one gave us the best performance. Now, we'll upload a file using the file picker. Here we have a WebAssembly module implementing the LZ4 block compression algorithm. After choosing the file, we can hit the upload button to run it through the system. Once the analysis is complete, the determined label of compression utility and the 96.9% probability associated with this class choice are shown. In addition, we can see the module's import functions, export functions, number of functions, file size, whether it's an ASM.js module or not, stats on the lines of code, and stats on the WebAssembly specific features such as data sections and table entries. Now we'll go back and start a new task. Now we'll look at the scanning functionality. We'll use the movie sharing website 300mbfilms.co as our example. This website contains a crypto miner that a user may not be aware of. Our tool will be able to show that it contains a WebAssembly module and identify it as a crypto miner. First, we enter the URL in the bar and then click the scan button. The tool will then run the page for 15 seconds to allow all resources to load. After 15 seconds, the results are shown. For each WebAssembly module found, we are given the classification results and the extracted features. The tool shows that the first module is indeed a crypto miner. The second module is a WebAssembly support tester used alongside the crypto miner. In addition, 5 screenshots of the scanned web page are shown to allow the user to verify that the web page they scanned was actually the one that they meant to scan. So now we'll go back. Alright, and that concludes our demo of the WASim tool. Thank you for watching, and we hope that you try this tool out.